always wanted to do this. Thank you. So I'll be talking about Python and home automation. I'll be talking about Python and home automation. This is too long, didn't read slide for all of you that will zone out or whatever. So pretty much in summary, what I want to say in this talk is everything that you need for your home automation system is already out there. You literally just need to get started and get it done. Please do not try to reinvent the wheel. That will be my second message. It's a really important one. I learned the lesson really, really hard way. And a great thing, the last one, is something that I learned 7 years ago when I switched from many years with PHP to Python and Django in particular, that if it really starts feeling wrong, it is wrong. Yeah, it's a really simple sort of rule to follow, and you'll appreciate it if you start acting accordingly to that one. So a bit about me. Yes, I was born in Slovakia, part of former Czechoslovakia, last century. And when I was young and handsome, I studied home automation and robotics at a university. 3 years ago, I finally I finally convinced my wife that building a shipping container house is a really great idea, and I should just do it. So I did. Well, I'm actually still building it. There is no such thing as finishing a house when you're building it by yourself. If you want to read about my adventures, that's the link to my pages about what I've been up to. Last time I updated in May last year, so the answer to the question when the next update is coming is soon. I've got some documentary almost ready. It's just, I just need time. I like open source software and hardware, and I believe that's definitely a way to go for something like home automation if you're thinking to do that. And as I said on my too long didn't read slide, everything is already out there. You just really need to glue it together with Python. No? Okay.
Not just the arrow?
Yeah, that's what I did.
Oh, that's what you did. No, it was a problem.
Every single time, by the way, I was banned at university to use Windows computers because every time I touched one, it just did this. Look, it's more magic. So why we actually do want to automate things? Laziness is pretty much the single reason, I believe. We want to automate repeatable processes. So for example, you don't want to switch on and off your heating system just to keep the house temperature on 22 degrees, right? So you have some sort of a heating system like underfloor heating or heat pump or whatever that will that has sensors and senses what the temperature is and either sort of cools down or warms up the place. You want to command and control, so you want to have you don't want to go you want to stand up from your sofa. You just want to type in a command to switch on the light or switch it off. And a really interesting one is to learn and predict things. So when you're doing data collection over years, you collect lots of data, whether that's about your house or about the weather, whatever, and you can sort of start learning about your environment that you live in or the environment that is outside of your house. So what's what's the big deal here? How this automation actually works? So we've got sensors, controllers, and actuators. The basic sensor is a button. So pretty much you switch on the button, light will go on. It senses that you change the state. You can have a light sensor. So for example, if it's getting dark outside, the lights inside will go brighter. You want to maybe use sound sensors for things like security. So if you leave the house and there is a noise that you detect, you want to raise alarm. Same thing for smoke. You can get, these days, really cheap smoke sensors that you just simply plug into Arduino, and you can do a simple experiment by lighting a fire next to it, and it will go off. And temperature sensors for just knowing what the temperature is around your house in rooms and act upon it. So you can have like blinds attached to it or whatever. As a controllers, I really like to use 80 mega or ARM chip-based boards. And so, for example, Arduino, which has the I guess it's C, that you program Arduinos with, or definitely Python, because, well, Python, obviously. For acting and changing state of things that sensors detected or control decided to change, use something like relays, solid-state relays, for example, for switching things on and off remotely, or you want to use servo motors, for example, for locking, unlocking doors. So I kind of currently, like this year, I'm thinking about the following 5 sensors of the home that I would like to build in. So the home, our place should have some sort of site. It should see that's obviously security cameras, ideally running some sort of embedded Linux, so I can talk to it, change stuff. Ultrasonic sensors, so you can detect approach. So if someone is approaching the door, the light can switch on. You want to see at night, because there is people coming at night, and if your cam doesn't have the night vision support, you kind of just won't see anything. And also motion. Yeah, currently I'm trying to solve, I've got a lot of visitors, and because I'm kind of facing back to them in my office, I don't see them often coming. So I want to have a cam with night and motion sensor in it, so I get an alarm in front of me, so to tell me that something or someone is coming. Hearing, sound sensors, as I said, again, security. Another good application for that is if you have a small kid, you just place a sensor in a bedroom so you can detect when the kid is crying, and the alarm can go off and just have to wake up and go there. As I said, smell, so smoke sensors for fire. Yeah, it's shipping container house, but I still would like to have that. It's got a timber frame roof, so wouldn't like to lose that. Touch sensors, in terms of, obviously, I'd like to, my approach to design of home automation system is I don't really like to rely, actually, on technology, because by default, you shouldn't really be trusting just technology. So I like to have the proper wiring with buttons and all that, and have like a fancy version of that sort of sitting on top, so I can control it if I like to by the home automation system. Or I can always just use just good old switch. Tablets. These days, you can get really cheap tablets running Android. You can glue it to the wall and have the interface, the control interface, or news or whatever, just literally in front of you. And then mobile and web interface, so I can either talk to the house using cell phone, or again use the web user interface on tablet. And temperature for, this is really long-term plan. for heating blinds or air conditioning, should we need that ever. But it's used, I'm already using the temperature sensor because it's really DS18B20s, really cheap ones, and are really nice, really precise, and it's one wire sensor that's just really easy to use. So you can just buy them in dozens and just use everywhere. Yeah, some bonus features. So to sort of improve on the laziness, you can have. My plan is to have like a full light control. So if someone is not in the room, you don't want to have the light switched on whole night or whatever. If someone forget to switch it off. You want to have the control if you're going at night somewhere, the lights should sort of go on and go off automatically, so you don't need to, because you're not really thinking when you wake up in the middle of the night. So that's light control. Audio and video, so something like MIF TV or some audio systems. And yeah, would be nice is a weather station or garden, like automated gardening. There is like a really nice set of projects using Arduinos, and so you can use it in gardening for irrigation, using sensors whether the plants have enough humidity and water in them, and they can. I think there is a project that's the plant will start screaming on Twitter that it's really thirsty and you need to sort of put some water in it. That's handy. So I'd like to have those. So build your own. Like, I'm not going to tell you how or what your design should be, because the design changes from house to house, and you've got different expectations, you've got different requirements for that. However, you have this stack of hardware, protocols, and software that you can already use and just mesh up together and use for your own home automation system. So, yeah, so what I usually do is, you have an idea for, yeah, I had a problem that when it got dark in the office and I didn't have a light in the I kind of was staring at a screen and it was just not funny. So I used Freetronics Ethermega and solid state relay, and I'm controlling like a LED strip, so I can control it using MQTT to switch it on and off. I had like really, really dodgy version. That was the proof of concept, and I sort of did the proper implementation and kind of production ready. It just kind of sits on my table right now. And this brings me to the do not try to reinvent the wheel node, which is sometimes you kind of sober up when you start writing something that you kind of sense that already exists, and you kind of just realize that your idea is definitely not new, that the proof of concept should not ever be used in production because it's just no. And then production-ready implementation already exists, so you should not, create your own telemetry because you just had that idea that you're creating a telemetry protocol. This kind of like might remind you of when you wanted to create a blog, and instead of writing a blog post somewhere, you started writing blog engine. That is exactly that thing. So in terms of hardware that you can get these days, there is well-known Arduino. Has everyone used or knows Arduino? If not, just yell at me and I'll explain what it is. I like Freetronics guys. They're from Australia, and they do like a really nice versions of Arduino boards. I use Freetronics because my kind of design is around network switch, power over Ethernet, and Freetronics, they have board that does that supports that, so I'm using that. And I really like Beaglebones. I've got the black one now that I call Brain. It's running Debian Linux. It's got a 2 gig flash, so the Linux just starts really fast. And there are some other boards that I don't use, but yeah, if you're keen, you can. In terms of protocols, this is sort of like, I wish I could discover this earlier. MQTT is used for telemetry, and I'll get to that. It's just really something that when I discovered how easy it is, I was really surprised. XMPP is well known as Jabber, or what Google used to use for GTOL back in the day. And something that I discovered last week, Socket.io, that gave me a bit of headaches. And I really liked that it's a GridSpy Lightning talk, because that gave me some inspiration for the real time. So everything in these protocols is real time, and it's really simple to implement, and there are production-ready libraries for Python. So yeah, that's software stack. Python Mosquito is the MQTT broker. I like to use XMPP. I discovered the first version, and the guy really follows the spec of XMPP, so it's really nice library to use. I just sort of, last week when I was doing research, I discovered a sleek XMPP. Haven't used it, but it looks really easy to use. And my framework of choice is Django, but go for your own. So MQTT, just quickly, is machine-to-machine connectivity protocol. It's, I think, at least 10 years old. It was created by IBM. It was designed as an extremely lightweight, and it really is, PubSub messaging transport protocol. So if you've got Debian or Ubuntu, you can actually just do this in 2 terminals, and you can see how it works. So in terminal 2, you install Mosquito Broker and Python Mosquito package, or you just pip install Mosquito. And then you subscribe to a topic, and you just simply say, okay, this is my topic that I'm subscribing. You don't need to create it, or there is no configuration, nothing. It's just, I'm subscribing to this topic, and whatever will write to the topic, I'll get. In the first terminal, I just wrote like a really simple script to connect to localhost, to the default port of Mosquito, and 60s timeout, I believe, and house announce, and I just say hello world. So you can, and then I ran the testing script, and you can see in the terminal 2, hello world, my test client. So that's how it works. It's beautiful. It's for small device. There is a Arduino library for this, so that's really nice, and a Python implementation API. So that's really nice. For just playing, you're just using the Mosquito_sub or Mosquito_pub to subscribe and publish to topics. Too long, didn't read. XMPP, it's Jabber, it's great. That is really useful in home automation for things such as real-time alerts. So if anything happens and during the messaging in MQTT, there is an alert, you simply send yourself a message that something happened, and you really should know about this. So, smoke sense and fire and that sort of stuff. I like to use it. I really like XMPP. I gave this a go last week because I really want to have real-time updates for the front end, for the interface. So that's Given Socket.io. I don't know, I'm really happy to get suggestions for anything better or different that will just enable me to get real-time updates from the backend, from the brain to my web UI. Bit of control theory. So what is it that we're actually doing here? So we've got a sensor that is taking the system output and measures that output. So for example, you figure out what the temperature is. You've got a reference, so you say, I want the temperature in a room be 22 degrees. And the difference between the reference and the sensor, so the actual temperature and the desired temperature, is the measured error that goes to a control that evaluates that and says, okay, it's still not warm enough. Go to the system, put the heating up, and yeah, just control. The simplest controller that you can create is, so you've got desired value and you've got some value from a sensor, And you can just say, if it's not on a desired value, just keep on going. When it gets to a desired value, just switch off and then just do nothing because you're the desired values or above it. And then when it sort of drops down again, so temperature, for example, goes up, down, at the point it goes below desired value, just switch it on again. So you have this bouncy temperature, so it can go, say, from 20 to 22 degrees, and it just goes up and down, up and down. It's really the simplest control that you can create. To go completely fancy, you go PID Controller, which has 3 different parts: proportional, integral, and derivative. Which the easiest example for that would be mixing of cold and hot water. So the PID controller kind of does that. So you switch both cold and hot at the same time. So it just gives you some sort of value, and then you sort of fine-tuning the cold and warm until you get that desired value out. So that's pretty much, in simple words, that's what PID controller does. This is a really simple implementation of PID control. The theory behind this is massive. Like, yeah, it took me quite a few years to finish off university, so it is big theory. I dumped some links, so because if the slides go out, so you can kind of have some reference points. Thank you very much.